Assalamualaikum warahmatullahi taala wabarakatuh, and hello to everyone. My name is Muhammad Kafi Abidillah bin Zainal from School Material Engineering. Today I would like to present fundamental of study carbon nanotube and its electronic applications. So for my part, I will explain regarding introduction and type of CNT. Okay, first of all, what is a carbon? Carbon is known to be the most versatile element that exists on the earth. So from the carbon we can use to produce a carbon nanotube. Carbon nanotube, they are a long hollow tube of carbon that are arranged in helical geometries. Carbon nanotube can be considered as a unique nanostructure, conceptually a prototype in one-dimensional 1D quantum wire. Carbon material also exists in the form of diamond, graphite and furnace. Okay, carbon nanotube considerable interest in investigating their physical and mechanical properties towards the developments of potential technology applications. Carbon nanotube also has exceptionally high thermal and electrical conductivity and possess excellent mechanical properties. Okay, from this figure, we can see that the carbon nanotube, they are a long hollow tube of carbon arranged in helical geometry to give the appearance of cylindrical chicken wire and giving a hollow 2D nanostructure made up of highly organized carbon mesh. Okay, this cylinder has a diameter on the nanoscale, conferring chemical consequence not normally observed with carbon material. On the other point, carbon nanotube has further electronic application and sport equipment. For example, Floyd Landis, he wins the 2006 Tour de France on his nanotube alloy bicycle. So that carbon nanotube having promising further electronic quantum wiring drug delivery system and even improving sport equipments. As I mentioned before, carbon is the most versatile element that exists on the earth. This versatility is due to their properties. Firstly, the properties of carbon nanotube, they are extremely strong. In fact, that the Young modulus for the strength of single wall carbon nanotubes is about 1 terapascal, making it 100 times stronger than steel and 1000 times stronger than spider silk. And finally, they have excellent thermal conductivity along the length of the tube but not across the diameter. So in addition, their electronic application can be determined by their shape and structure. Nanotube come in variety of conductivity range from semiconducting up until superconducting under the right condition. Those the right condition which are about 20 Kelvin, which is cool to be practical for days to days. Okay, type of carbon nanotube. There are two main types of carbon nanotube, which is single wall and multi-wall. Single wall carbon nanotube can be considered to be forms of a single layer of graphite, or the other term called as graphene layer, by the rolling into similar cylinder. Similar cylinder is created by the involving only hexagonal rings with double and single carbon-carbon bonding. Single wall carbon nanotube forms by the rolling of a single layer of graphite. The choice of the rolling exists relative to the hexagonal network of the graphite sheet, and the radius of the closing cylinder allow for the different type of single wall carbon nanotubes. This figure shows the diagram of single wall carbon nanotubes. And four multi-wall carbon nanotubes can be considered as a multiple layer of graphite rolled in on themselves to form a tube shape with a different diameter. The length of the two types of tube can be up to 100 of micron or even centimeter. These concentric nanotubes are held together by secondary van der Waals bonding. This figure shows the diagram of multi-wall carbon nanotube. Okay, comparison between single wall carbon nanotube and multi-wall carbon nanotube is: single wall carbon nanotube are most desired for fundamental investigations of the structure or property relationship in carbon nanotube. Single wall carbon nanotube are very important variety of the carbon nanotube because they exhibit electrical properties that are not shared by the multi-wall carbon nanotube variant. Okay, that's all. Thank you for watching my video.
Hi everyone, my name is Chang Menxin from Materials Engineering. Now I'm going to continue the presentation on the structure of the carbon nanotubes. As can be seen in this diagram, carbon nanotube can be viewed as a roll-out of graphene sheet, which form a closed cylinder, where the graphene sheet is formed as a 2D sheet of the carbon atom arranged in a hexagonal array. Different way of the rolling up the tube will produce different types of carbon nanotubes, as the type of carbon nanotube depends on the graphene sheet is oriented on rolling. The atomic arrangement on the carbon nanotube surface will have its own unique properties, so the structure usually is related to the properties of the carbon nanotubes. The structure of carbon nanotube is described into two vectors, which is the chiral vector and the chiral angle. chiral vector is described by two integers n and m that located the hexagon of the network which will match after nanotube rolling with the hexagon that is in the origin of coordinate. Next, the chiral angle is described the amount of twists in the tube that formed by the nanotube rolling direction and the direction of the common edge of two adjacent hexagons. We can see here the structure of the carbon nanotube is divided into two, chiral and achiral. Chiral is the carbon nanotube that have a screw symmetry, while the achiral carbon nanotube have a high degree of cylindrical symmetry. In achiral carbon nanotube is further divided into two, which is armchair and zigzag. In zigzag, the two edges of each hexagon are parallel to the cylinder exists. The chiral vector is n0. Because it is the parallel, so the theta is 0 and one of the vector is 0. Next, the armchair is the two edges of each hexagon are perpendicular to the cylinder exists. The chiral vector is n and theta is 30 degree. Due to the armchair is perpendicular to the cylindrical axis, so the vector usually is the same, either m or n, and this is equal to each other. Next, we can see more clearly in this diagram. Armchair is the graphing sheet is rolled up along the vector smaller than the chiral angle, while in zigzag is the graphing sheet is rolled up along the vector that greater.
I'm Li Chili. Today I'm going to present the properties of carbon nanotubes. Now we are going to focus on mainly four types of properties, which are the mechanical properties, thermal properties, electronic properties, as well as the aspect ratio properties. There are two types of mechanical properties, which are the tensile strength and the elasticity. The carbon nanotube is known as the material which is as stiff as or even stiffer than the diamond. This is because the bond that forms inside it is the sigma bond, and the strength is further increased by the similar cylindrical structure. The carbon nanotube has the highest tensile strength as well as the highest Young modulus among all the other existing materials, and it has been recorded that the highest value has reached to 1 terapascal. Different type of carbon nanotubes has different tensile strength, but basically the multi-wall carbon nanotubes has a higher value of it because of the summation of the highest Young modulus of the single carbon nanotubes and the van der Waals force. The carbon nanotube is said to be strong and behaves elastically to different types of deformation, and these deformations are tensile, twisting, and bending. During these deformations, the carbon nanotubes can buckle elastically, and if the tensile strain is below 15%, the deformation is said to be recoverable, and it can definitely be bent into a very high angles. The carbon nanotube has a high thermal conductivity, and the mechanism that used in transferring heat is known as the thermal conduction mechanism. Let's see what affects these thermal properties. First of all is the morphology. And generally, multi-wall carbon nanotubes has a lower thermal conductivity because of the thermal energy is usually transferred only at the outermost wall, and the single wall carbon nanotube has a relatively lower defect density. Next is the chirality inside the atomic structure, and lastly is the defects that form when the non-hexagonal carbon rings is combined into the carbon nanotubes, and this will definitely reduce the thermal conductivity because of the local thermal resistance. The carbon nanotubes has a high electrical properties, and as well as it has the superconductivity properties, and these properties is highly related to the surface texture, and the carbon nanotubes has a very smooth surface without any dangling bonds. Therefore, it can reduce the scattering of the carrier and hence increase the mobility of the carrier. The carbon nanotubes has a small capacitance as well, and it can be the semiconducting materials depends on the helicity indices. Last but not least, the carbon nanotubes has a high aspect ratio. This means that only a very small concentration can reach the similar electrical conductivity additional conductive entities. Thank you.
Hi, my name is Nur Aida Husna binti Muhammad Mahyuddin. I'm going to present about the synthesis of carbon nanotube. There are basically three important types of synthesis of carbon nanotube with a laser ablation method, arc discharge method, and chemical vapor deposition. We're going to start with laser ablation method. In the laser ablation process, a pulsed laser vaporizes a graphite target in a high temperature reactor. The laser ablation method yields around 70% and produces primarily single-wall carbon nanotube with a controllable diameter by the reaction temperature. It is more expensive to be compared to either arc discharge or chemical vapor deposition. This is the method of how to produce carbon nanotube by using laser ablation method. A well-mixed acetylene air mixture is burned inside a tube furnace. A laser is used to vaporize a metal target, either ferrum or nickel. The post-flame exhaust gas is mixed with the metallic vapor and allowed to cool. During cooling, carbon nanotubes are formed. Next, arc discharge method. Electrodes are composed of high purified carbon graphite, performed in the chamber with an inert gas, either helium or argon, using a fairly low voltage power supply to strike an electrical arc between two carbon electrodes. The carbon inert can be enriched with particles of transition metal in order to aid synthesis. Pressure runs very high and carbon atoms are ejected. Atoms migrate toward colder zone within the chamber. Nanotubes form in the arc and collect on the anode, along with the host of other carbon byproducts. Producing carbon nanotubes in high yield depends on the uniformity of the plasma arc and the temperature of the deposit forming on the carbon electrode. Last is chemical vapor deposition. The catalytic vapor phase deposit of carbon was first discovered in 1959. CVD is the most economical method due to the cheapest source of material. During carbon vapor deposition, a substrate is prepared with a layer of metal catalyst particle, most commonly nickel, cobalt, iron, or a combination of them. The diameter of the nanotube that are to be grown are related to the size of the metal particle. The substrate is heated to approximately 700 degrees Celsius. To initiate the growth of nanotube, two gases are blended into the reactor. A process gas such as ammonia, nitrogen or hydrogen, and carbon-containing gas such as acetylene, ethene, ethanol, and methane. Nanotube grows at the site of metal catalyst. The carbon-containing gas is broken apart at the surface of catalyst particle, and the carbon is transported to the edge of particle where it forms the nanotube. That's all. Thank you.
Hi, my name is Nazira binti Yaakob, and I will explain more about application of carbon nanotube. So, carbon nanotube are widely used in electronic application. This is because we have known that carbon nanotube have good electrical properties, thermal properties, and mechanical properties. So this is the application of single-wall carbon nanotube, which is thin film transistor, logic circuit, stretchable transistor, stress sensor, electrostatic dissipation, and filler and reinforcement. For your information, carbon nanotube is divided into two, which is single-wall carbon nanotube and multi-wall carbon nanotube. Single-wall carbon nanotube desired for thin film transistor due to its excellent charge mobility and low cost processability. Single-wall carbon nanotube important to report the mobility and on-off ratio. Since the thin film transistor is affected by the density of single-wall carbon nanotube network and channel length. The higher density of single-wall carbon nanotube and small channel length single-wall carbon nanotube network will produce higher mobility but lower on-off ratio of thin film transistor. This is actually thin film transistor can be divided into many devices, but I will explain on gate dielectric and integrated circuit. Gate dielectric. Single wall carbon nanotube thin film transistor is the important component of gate dielectric. By conventional microfabrication technique or printing approaches can be applied. Integrated circuit. Since the polarity of single wall carbon nanotube can be controlled by charge transfer doping, CMOS, which is a type of inverter, complementary metal oxide semiconductor can be conducted. Logic circuit. With better control devices, polymer sorted single carbon nanotube can be used for constructing logic circuit. Component of logic circuit, for example, NAND gate and NOR gate, demonstrated using polymer sorted single wall carbon nanotube on flexible substrate. And the next is inverter, flexible inverter, which is CMOS. I mentioned before, complementary metal oxide semiconductor, constructed using only P-type single wall carbon nanotube transistor and bipolar single wall carbon nanotube transistor, or a combination between P and N-dope single wall carbon nanotube transistor. Stretchable transistor. Stretchable transistor is used in health monitoring devices and stretchable display. Stretchable display. This is due to its possibility sliding and buckling network, which is suitable to apply in stretchable display. Strength sensor. Single wall carbon nanotube can change its electrical properties, and it can sense strengths of the micro scale. Experiment from the researcher said that linear change in voltage across the film when subjected to tensile or compressive stress. Electrostatic dissipation. Film with single wall carbon nanotube incorporated had sufficient electrical conductivity dissipate electrostatic charge. This is the properties of single wall carbon nanotube, which have good electrical conductivity, can be applied in some aircraft component, which to provide electrostatic discharge and electromagnetic radio frequency interference protection. And the last one is filler and reinforcement. 100 tons per year of single wall carbon nanotube have been used as a filler in the anode of commercial lithium-ion rechargeable batteries, and also it is be used as a reinforcement of the cathode of lithium-ion in rechargeable batteries. That's all from me. Thank you.